George, Hannah, Irish, Jacob, and Kim. 1, 2, 3, 4, 5, 6 people have playoff tickets for a hockey game. They sit in the adjacent seats, A3 to A8. If I'm sitting them in seats, am I giving them order? Yeah. If you sit people in a plane, are you giving them order? Yeah. People say, well, it doesn't matter. If it doesn't matter, people wouldn't pay expensive amounts of money to have an aisle seat or to have a window seat, right? So it does matter. The moment you put someone in a seat, order matters, right? Same as like if you throw people in a van and you put them, some of them in the middle and some of them in the back, you now order them in that van. You just tuck them in and they'll just kind of sit in the middle. Tickets. Okay. So here it says, in how many different ways could we set them in seats A3 to A8? So A3, A3, A4, A5, A6, A7, A8. Do you agree? Does it say anyone has to sit on the left and the right, and someone sits in the middle, and someone's fighting, or anything like that currently? Does it say anything like that? So how many people do I have for this one? 6. Then 6, 6, 6, 6. Would I ever sit a person down if I did that? 6 here, and then no one sits down, and then 6 here, and then at the end when I'm done, no one is sitting. Everyone's still standing waiting to be sat down. So this is 6 then. 5, 4, 3, 2, 1. The moment I give blanks, am I ordering something? The fundamental counting principle, am I giving it an order the moment I give blanks? Yes. So it's a permutation, right? So you can't say, oh, it's a combination. I'm going to use blanks. That's actually counterproductive. If I use blanks, it's a permutation, correct? I can't say, oh, it's a combination, blanks. Well, now you're standing them in a specific order and giving them orders, so it can't be a combination, okay? This is what we're going to move on to today. So this we can rocket count to 6 factorial. We could also call this 6p6, same answer, and the answer is 720. All of these all mean the exact same thing. George and Hannah are dating, and how many of the arrangements in A would they be sitting together? So let's find that out. 1, 2, 3, 4, 5, 6. I'm going to make them sit together on the far left. It's how I always start, right? But they don't have to stay on the far left. It didn't say that. If it said they sat together in the middle, I'd hook them together in the middle, and then I'd be done, right? I'd just do my normal math, call it a day. But this says they just have to be together. So how many do I have for this one? 2, because it could be George or Hannah. Yep. Then I make one of them sit down, and then I have 1, and then I have how many people left? 4, 3, 2, 1. Now I have those 4, and I take my George and Hannah, and I say 1, 2, 3, 4, 5 cases, correct? So it's 1 more than the number after the hooked together numbers, okay? Because this is 1, and I can put them here 2, 3, 4, or 5 at the back, right? So it's always 1 more, times it by 5, and I get 240. Just before the game, George and Hannah have a disagreement, and they don't want to sit together. Once again, we're not sitting them together. Is the best way to not sit them together do like 17 cases where we don't sit them together? What would be the best way if we don't want them to sit together? Find all the ways we can sit them. Total, right? Which we found in the very beginning. So we need total ways 6 people can sit. Which is A. A is 720. And then we minus off George and Hannah sitting together, because we want not them sitting together. So if we take off all the cases where they sit together, we'll have left over them not, correct? Which is 240, and that equals 480. And remember, on a test, we're writing out sentences. I would expect you probably have sentences now, hopefully, but maybe not. So we should say there are 480 ways that George and Hannah cannot sit together, right? Okay. Next page. Determine the number of arrangements of the word Canada. I get Canada, I immediately rewrite it. C-A-N-A-D-A. Right? So every question I'm going to do now is going to have 3 factorial in the denominator. So you're like, well, when won't it? Never. So 3 factorial, correct? That is the best thing that was a gift. That's like a gift. When I learned this, I was like, so there's never a time where I don't put 3 factorial? And they're like, No. And I was like, okay, I can get on board with that. That's easy. I just 3 factorial immediately, right? So it's the very first thing I always do. So must begin with a vowel and end in a consonant. Okay, cool. 3 factorial on the bottom. Canada 6 letters. And I can do blanks because words are always permutations. Order matters. Or someone could come up and reorder your name and call you that. And say, ha, it's the same thing. It's not. It's permutation. Order matters, right? So it must begin with a vowel. How many vowels are in Canada? 3. So we're going to begin with a vowel. So I have 3 options. End in a consonant. Consonant is not a vowel. How many consonants are there? 3. Now, little Crystal in high school did not comprehend this. I'm like, I've used up 6 letters. I have not used up 6 letters. I had 3 options for this blank and 3 options for this blank. And in each blank, I can only leave a letter. Correct? So how many letters have I left behind? 2. So how many do I have left? 4. You guys are already in a better boat than I was. I just guessed. It was bad. I ran out of blanks. I didn't have a clue, and I never asked my teacher. Okay? So we technically get 9 times 4 factorial over 3 factorial. Why do I say 4? 4, 3, 2, 1. Where do I get the 9 from? 3 times 3. Right? And what do you get for an answer? 36. Is that true? Yes? Everyone just goes mute, so I don't know if they're... And when you whisper, okay, yes. Okay. Must begin with C and D in that order. So it has to be C and D, which means it's going to be 1, 1, 1. And I get people doing this. They're like, yes, I got this. I'm so smart. I got this. 1, 1, 1. Used up, okay? And it begins, yes, okay, cool. And then I have 3, 2, 1. And then my answer is 6. And then they move on. And the answer is there. The answer 6 is there. And you don't even know you're wrong. You don't even know you should be sad. You're just like, boom, answer's there. I got this. But if you remember at the beginning, to divide by 3 factorial, what do we get? 1. There's one way. Because, guys, think about it. It would be C, N, D, A, right? We move those A's around, it wouldn't change. So it is only one way. You have to remember to divide that 3 factorial. Okay, C and D must be together in that order. Does it say at the beginning this time? No. So I'm going to immediately put a 3 factorial. Because I'm a rebel, immediately going to put a 3 factorial down here. Because I know I'm going to need 3 factorials on the bottom. Yes? I don't want to forget them. That is the top. Oopsie. Okay, so C and D must be together in that order. 1, 1, 1. Then I have 3 A's left. 2, 1. But now I can disperse those between the A's, correct? So I have to times it by 4. So the answer to this one is 4. C and D must be together in any order. 1, 2, 3, 4, 5, 6. So this would have how many now? 3, 2, 1, 3, 2, 1. If it said together at the beginning, you'd be done. But it just says together. So what do we still have to multiply it by? 4. So our answer is 24. We're bypassing 7 and 8 for a few seconds. We're going to move on, remember? These ones we're going to go through today, and then combinations. Okay, your turn. In how many ways can the letters corporation? C, O, R, P, O, R, A, T, I, O, N. Right? So corporation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But on the bottom, I'm going to have 3 factorial, 2 factorial. Okay, it says the vowels always come together. So we have these, that, and that. So we have 5 vowels. We agree? So we're going to hook the first 5 letters together. And we get 5, 4, 3, 2, 1. How many letters are left? 6. 5, 4, 3, 2, 1 times 7. Do you need to use a multiplication symbol there? Like, am I going to annihilate you if you put a dot? No. Am I going to annihilate you if you put multiplication symbols instead of dots? No, they all mean the same thing. The only reason why I do this is that I'm trying to show you that this is 7 cases. That's where I'm getting the 7 from, because a lot of people get stuck like, you're just putting a 7 at the back. Why are you doing that? It's because there are 7 places that this 5, 4, 3, 2, 1 could be dispersed within the 6, 5, 4, 3, 2, 1. Does that make sense? I need you guys to understand why memorizing scares me. You know that, because memorizing means you could not remember. Yep.
There's only like 6 spots left. How come it's times 7?
So there's 6 spots left. That first one counts still too. So that's 7. So you're right. There are 6 spots left, and that first one counts as number 7. You got it. Okay. What do we get? A, B, C, or D? C? A? B? C. Okay, then we have engineering. E, N, G, I, N, E, R, E, E, oh my gosh, R, I, oh, look at this N problem I got going here. N, G, maybe carry this N over here.
Why'd you put 4 each?
Because I don't know. Really? Oh, I don't know. Let's try again. E, N, oh no, why are you so aggressively sick? N, G, I, N, E. Did it again. No. Ah! So glad we're podcasting this. E, N, G, I, N, E, E, R, I, N, G. Third time's a charm, guys. Third time's a charm. That's what I got hung up on, was the stacking of letters, not the mathematics. You're welcome. I'm here all year teaching you, and that's what I just did. You're going to be blessed with so much knowledge. Promise. And I got this. I got this. It's good. Everything's awesome. It's going to be okay. I'm maybe just talking to myself. All right. So on the bottom, we're going to have 3 factorial, 3 factorial, 2 factorial, 2 factorial. Which took a long time to get there, but we got there. And then 3, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, how many arrangements can be made out of, 11, 10, 9, 8. Why did I do the blanks? I don't know. It's just 11 factorial on the top. What do we get? A, B, or D? Because C is stupid. B. Good. Absolutely. Yep. Yep. Yo.
You know when we like had in the classroom?
Yeah.
Like the answers are wrong. Maybe like marked off.
It's homework check. Yep. It's just that you worked on it.
Yeah.
I'm expecting it to be not correct.
Yeah.
I just want it completed. Yeah, that's okay. Just homework, right? We're just learning. Okay. Okay, the next one says, determine the number of ways the letters in kitchen, K, I, T, C, H, E, N. So I literally just wrote out 7 letters for no reason. That just means I don't get a denominator, correct? And that can happen. You're not all going to have a repetition. The KCN must be together in the order KCN. KCN, order KCN. Boom, boom, boom. Then I have 4, 3, 2, 1. Does it say together at the front? No, so I still need to multiply by 5. So I get 120. The letters KCN must be together, not necessarily in that order. So same thing, but the front is going to be 3, 2, 1. So we're going to go 3, 2, 1, 4, 3, 2, 1 times 5. So I get 720. And here we have Anne, Brian, Colin, Diane, and Eric go to watch a movie in 5 adjacent seats. How many ways can Brian sit next to Diane? Does it say in the order which they need to be? No. Thanks for answering my question. 2, 3, 4, 5. So, how many do we have for the first 3? 2 and then 1, because we sat someone down, right? And then we have 3, 2, 1, and then we're done? No, what do we have to do? Times it by 4, because we have 4 places for it to move. So we get 48. Anne is like, Eric, you're an idiot. And she refuses to sit next to him. So the easiest way to do that is to not find the cases where Anne and Eric are not sitting together. Remember? What we do is we do total minus Anne and Eric together. Because when I take off all the cases where Anne and Eric are together, I'm going to be left with Anne and Eric not together, because that's opposites. So the total ways I can do this is 5 factorial. There are 120 different ways that these 5 people can sit together. If you think, wow, that's not much, there's 5 people sitting. There are 120 different ways you can have those 5 people rearranged in those 5 seats. Kind of crazy to think about it. Because when I walk up with 5 people, I don't think, oh wow, there's 120 different ways we could have sat down. But there are, right? So 5, 4, 3, 2, 1. Okay? Then we need Anne and Eric to sit together, which is the exact same as Brian and Diane sitting together, but we can show the work if you'd like to. So Anne and Eric sit together, 2, then 1, then 3, 2, 1, times 4. And so we get 48. So if we take 120 ways they can sit, and we take off the 48 ways that they can sit together, I'm left with 72 ways they cannot sit together. Right? Okay, number 5. Determine the number of the ways anteater can be arranged. Yeah, sorry, Colton.
I answered my question.
Okay. A, N, T, E, A, T, E, R. Remember, if you don't understand something, put your hand up and ask it. Now this one says the word begins with a consonant, ends in a vowel. So it's going to begin in a consonant. We have 1, 2, 3, 4, 5, 6, 7, 8 letters. And before I start doing anything, because I get super excited that I might be able to do this question, I have to put 2 factorial, 2 factorial, 2 factorial in the denominator. Because you guys get excited when you see a question you know how to do. You'll forget to put the denominator on. You're like, I got this. I know, begin, end. Yes, this is what I can do. And then you forget the denominator. Okay, so put the denominator in first. Begins with a consonant. So we have 4 vowels and 4 consonants. So it's 4. Begins with a consonant. Ends in a vowel. We have 4. How many letters have I placed? 2. Each blank holds a letter, correct? So how many do I have left? 6, 5, 4, 3, 2, 1. So this should be 360? No, 2 times 2 is 4. Take that one off. 720 times 2. 1440? Yep. Then we have the consonants must be together. 1, 2, 3, 4, 5, 6, 7, 8 divided by 2 factorial, 2 factorial, 2 factorial. There are 4 consonants. I'm going to hook them together. 4, 3, 2, 1 times 4, 3, 2, 1 times 5. What do we get? Pardon? 360. You agree? Agree or disagree? The words must begin with the T's. Does it say T's together? No, it says must begin with the T's. So we're not going to have cases. 1, 2, 3, 4, 5, 6, 7, 8 divided by 2 factorial, 2 factorial, 2 factorial. So there are two t's. It's going to begin with them. 2 times 1, and then 6, 5, 4, 3, 2, 1. But because it says begins, we don't move this. We don't get 7 cases. Okay? So we're going to get 720 divided by 4, 180. And then the A's can't be together. So do we try and find all the cases where the A's can't be together? Like A's can't be here and here, and then here and here. Is that the fastest way? Well, we do total. So 8 factorial divided by 2 factorial, 2 factorial, 2 factorial. Can someone tell me what the answer to this is? 8 factorial divided by 2 factorial, 2 factorial, 2 factorial. Or 8 factorial divided by 8. What's 8 factorial divided by 8? 5040. So when using the word anteater, there are 5040 different words I can make. Right? Total. I can't find 5041 somewhere in the world. 5040. Then I have to subtract off the A's together, which is the same as the T's together, but that's okay. We'll show it anyway. Oh, those are T's to begin with T's. 1, 2, 3, 4, 5, 6, 7, 8. 2 factorial, 2 factorial, 2 factorial. So A's together, there are 2 of them. So we're going to hook them together. 2, 1, and then 6, 5, 4, 3, 2, 1 times 7. Because this one doesn't say, the T's have to begin with it. The A's don't have to. What's 5040 divided by 4?
1260.
1260?
Is it 5040 divided by 4?
Yeah. Okay. What's 5040 minus 1260? What is it?
3,780.
Yeah.
Where did we get the 1,260 from?
This. So 5040 divided by 4. It's 1,260. Yeah, so this 7654321 makes 5040. The 2, 1, and 2, 1 cancel off, divided by 4. So it should be 1,260. When you do the math. All right, let's go backwards to example 7, please. So here it says Julie's home is 3 blocks north and 5 blocks west of her school. So if I start her school here, I'm starting down here because I need to go north and west. So I'm going to have to go up and left. Her home is 3 blocks north. 1, 2, 3, and 5 blocks west. 1, 2, 3, 4, 5. That would be one way you could get there, correct? Like you could just go straight up and then straight left, right? But there's also all these pathways in between. I'll pretend that's straight. That's not. It's going to bother me. That's not much better. So those are all the pathways that she could do that 3 by 5, right?
So this is essentially like so I know it's 4 by 6.
No idea, but
I don't know, that's just my brain right now.
this is just 5 by 3. Yeah. So you're okay. All right. So technically, we have Julie's home is 3 blocks north and 5 blocks. How many routes can Julie take from home to school, traveling either south or east? So what we can do is, we technically know that Julie has 3 downs she has to complete in some way. 3 downs. She just gets down 3 ways. She could go down all the ways, or she could go over and then down, over and down, over and then down. She has 3 downs she has to complete to get there somehow, correct? And then she has rights. She has 1 right, 2 right, 3 rights, 4 rights, 5 rights that she has to complete. So technically, she's going to have to do 3 downs somehow and 5 rights somehow, correct? She could go all right, then all down. She could go all down, then all right. She could go right, down, right, down, right, down, right, right. You know what I mean? But it doesn't matter. We're going to just treat it like the word dirt, because she has to complete 3 D's and 5 R's. Does that make sense, though? Like she has to complete all the D's and then all the R's? So that would be the same as having the word dir. Dir. Okay? And if I said, okay, how many different words can I make from dir? Dir. How would you do the question? How many different words can I make from dirt? What would you do? So you'd have 8 blanks. 4, 5, 6, 7, 8, yeah.
And then
Divided by 3 factorial and 5 factorial, yep. What would I do with those 8 blanks? You have how much in the first blank? 8, then 7, then 6, 5, because there's no restrictions. If they said she had to go down first, that would be different, right? Then I'd have restrictions. But they just want the number of ways that she can do this. We agree? If it was she had to go down first, well, then you'd have 3 ways to do that. But there's nothing about that. Yeah.
Just because we said that it was like 8, 7, 6, 5, 4. So could we just do 8 factorial?
Absolutely. Yeah. So this is 8, 7, 6, 5, 4, 3, 2, 1, and then next, can we just do 8 factorial? Absolutely. How many roots would it be? Anyone get an answer? 56? So there's 56 different routes she could take to get from home to school because she has to do 3 D's and 5 R's. Yes? Kind of makes sense? Okay. Example 8 has 2 separate scenarios here, or 2 separate little routes. This little, when they're connected, I always put a big old dot in the middle. I just do this. I make an aggressively large dot. What does a dot mean? Multiplication. So it reminds me that I just have to do this one separately from this one, and then I just have to do what with the 2 of them? Multiply them. So here it says, a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. Determine the number of routes possible if the bus must always move close to the concert hall. The reason why they say that is if the bus doesn't have to move close to the concert hall, we have infinite. Because it can just like, I'm bored, I'm going to loop here. Okay, then I'm going to come out, and then I'm going to loop here for a little while. Like, what would it be? You couldn't give an actual you couldn't give an answer other than infinity, right? Because who knows? How tired are they? I don't know. Are they a lost person? Can they not take directions? So when they say it has to always move to the concert hall, you're just always going to have to do that, or they could infinitely circle themselves, right? So let's do the first one ourselves. So we have a down, a down, a down, a down, and a right, a right, a right. So I have to do the word de, er. And then I have to do the other one. So this one would be de, er. Yeah? You find the ways for those 2. Try it out. Come on. join me. So this first one, we're going to have 4 factorial, 3 factorial, and then it's 1, 2, 3, 4, 5, 6, 7 letters. So 7 factorial on the top. I think it's 35. And then this one, you're going to get 2 factorial, 3 factorial, and then on the top, you're going to get 1, 2, 3, 4, 5. Now, they're going to give the answer to this with a plus sign in between, just so you know. That'll be an answer on your test. It'll be wrong, but there'll be an answer there. So if you don't remember that you have to multiply them, your answer will be there, it'll be wrong. Now, the reason why you multiply them is not just because I put an aggressively large dot in the middle. That's my last-ditch effort to be like, maybe that's going to stick in your head when we get to a test. The reason why you actually multiply, to understand why we're doing this, is because we need to take the top paths and the bottom ones to get to the concert hall, correct? We have to take the top and the bottom. If we use the word and, what does and mean we do, guys? Multiply. And add seem very similar, but they're not the same, right? So if I use the word and, I have to multiply. I need to use these paths and these ones. I can't just go forward in time and hit these paths and get to the concert hall, correct? If you use a plus sign, you're saying I could use these or these. And that's not true. I have to use these and these to get me to the concert hall, correct? So this one here we have to multiply, and it's 10, so you get 350. Can you flip to the or terms, number 6? We just did the or terms 1 to 5. Oops, I need to plug that in. You're going to have to do the or term number 6 on this side. So I want you to do A, B, C, and we're going to go through them, and then we're going to do combinations. So A, B, C, but I'm going to go back here for people who want to copy that down. So, last thing to do is combinations. We've done permutations, now we do combinations. Selection of elements which the order of the section is not taken into account. Or the selection is what that should say, but okay. Determine when order matters. A committee of 9 people chooses 3 people to be president, vice president, secretary. Does the order in which I pick them change the outcome? President, vice president, secretary. Do they have specific jobs?
Yes.
Yes, it matters. This is a permutation. I gave them jobs. Boom, boom, boom. Jobs. Permutation. Because if you're picked first, let's say you're the president, and second you're the vice president, and third you're the treasurer. So order does matter. You get a different job. Okay? So this one would be 9P3, or it could be I have 3 blanks. This is the president, this is the vice president, this is the secretary, and it'd be 9, 8, 7. Same answer, right? What's 9 times 8 times 7?
I don't see floats.
What do you get? 504? So there are 504 different ways I could pick these 3 people from 9. Okay? Giving them specific jobs. The next one says, a committee of 9 people chooses 3 people to form a 3-person subcommittee. Do those 3 people have jobs? No, it doesn't say they have jobs, right? We can't be like, I wonder if they have jobs. If they had jobs, they would be told they had jobs, right? So you're not gonna, you can't take the question to the teacher and be like, I would really like to know if they all have different jobs. The question is the question, right? So if it doesn't state that they have different jobs, we have to assume that they're just 3 people on a subcommittee, correct? So if you're picked first, second, or third, does your life change in any way? You're on the subcommittee or you are not, correct? That's it. So then this one would be 9C3. Now a whole bunch of people are like, okay, cool. They were like, it's a combination. You guys are saying that to me. You're like, it's a combination, slut. Order doesn't matter, right? And I'm like, yeah. And you're like, it's for sure a combination. And I'm like, mm-hmm. And you're like, yeah, order doesn't matter. Mm-hmm. And then you go like this. The moment you draw a blank, what are you telling me it is? A permutation. So you're like, it's a combination. I believe it's a combination. And then you start doing this. It's a permutation. So you can't do that. So that's substantially less committees, correct? Because I'm not ordering them. I'm just taking those 3 people and they just get to go on the committee. So it should be a smaller number when it's a combination because order doesn't matter. Okay? This is the formula for NCR. NPR, just so you know, is n factorial over n minus r factorial. It does not have this extra r factorial. That extra r factorial gets rid of the cases where it would be different, okay? You divide them out just like we did with repetition. It gets rid of those places where the cases are actually not different because it's not a vice president, president, and secretary. Okay? Yeah.
Will we ever have to like use that formula?
If I took away your calculator, yes.
Is there no calculator section?
No.
Essential.
No, it's AP. AP calc.
AP.
No, bro. No. You know what I'm saying? I could, but I'm not going to. You just said, can I? I could. No. Still a no. Darn it. All right. So, can I get you guys to pay close attention? Put your pencils down. I want everyone to pay attention to this. This only works with C's, okay? So, if I do 9C3, you guys told me that, my friends, was 84, okay? This, I repeat, only works with C's, okay? This is actually the same as 9C6. It is also 84. Do you see the common difference between 9 and 3 is 6? And the common difference between 9 and 6 is 3. This only works with C's, but why? Okay, so I need everyone to put the pencils down. You're all paying attention. So my formula is NCR equals n factorial over n minus r factorial, Do you agree? That's the formula. If I am doing, if I'm doing 9C3, and I say that equals 9C6, that's true, right? Because I told you that. But why? Well, let's plug into the formula. So this would be my N, and this would be my R, because it's NCR. We agree? Okay, I'm going to plug it in. You're not going to do any math. You're just going to follow along. N factorial would be 9 factorial over 9 minus 3 factorial, 3 factorial. We agree? Equals, so this would reduce to 9 factorial over, what's this? 6 factorial, 3 factorial. We agree? Okay, let's do the other side. So the other side of this would be 9C6. So this is my new N, this is my new R. Have to be the same N. So I get 9 factorial over N minus R, so 9 minus 6 factorial, 6 factorial, which equals 9 factorial. What's 9 minus 6? 3 factorial, 6 factorial. 3 times 6 and 6 times 3 is the same answer. Correct? 6 factorial times 3 factorial is the same as 3 times 6 factorial. Is 6 times 3 the same as 3 times 6? 18? Yes. Correct. Raise your hand up. Speak your mind. Ask a question. It won't be stupid. Other people are probably thinking it. Let's go. Chippity chop.
I'm just trying to think.
9C9 and 9C12 better.
You would need it to be the common difference. So if you went 9C9, it would be 9C0. Is the difference between the two. So if I went and that one's a harder one to comprehend. So let's say I do this. Everyone's paying attention. Say I do 18C10, right? That would be the same as 18C. Now watch. 18 minus 10. Which is the same as 18C what? 8. It's the common difference. Does that make sense? It only works because the NCR formula has an n minus r factorial and r factorial on the bottom. So if I gave you, for example, 9p6, That is not the same as 9p3. Because I can represent it with blanks, right? This one would be 1, 2, 3, 4, 5, 6 blanks. 9 times 8 times 7 times 6 times 5 times 4. And then this one would be 3 blanks, 9 times 8 times 7. Those are blatantly not the same. Correct? It only works with C's. The other thing that's weird with C's, on your formula sheet, which is over here, not over there. If you look here, it says NCR equals these brackets with NR. Do you see that? So what it says over there is NCR equals NR. So if my answer, if my answer is 9C3, they could give the answer in the multiple choice like this. 9, 3. Means the same. So if you ever see a multiple choice answer that's like 10, 4, that means 10C4. Okay? You don't have to memorize that. It's on your formula sheet, right? Like NCR equals NR. Like they show it on the formula sheet. So if you're like, man, I don't remember what that, oh, I get these brackets in my multiple choice. I don't remember what that means. Go to your formula sheet. Go look at the bracket and be like, oh, it's NCR. That's it. Okay? All right. So put in 10C4 and put in 10C6. 10C4 and 10C6.
I don't even know if it's C in.
By the P. What is 10C4? Oops. What's 10C6? 210. And that's same as 10.4 equals 10.6. I already showed on the other side how we do it with the factorial, so we're not going to do that here. But those are the same. So then they're showing here NR is the same as N over N minus R. It shouldn't have these in it. That's an oopsie. We're going to go to example 1. Your problem now is going to be, is it a permutation or is it a combination? That's going to be your problem from now until the end of the unit. You have to know if it's a perm or a com, because you deal with them differently, right? So license plates. Does order matter on a license plate? Yeah, it's a permutation. What about a phone number? What about an actual number, like 753? What about odd 4 digits? Those, yes. What about making a committee and it having 3 parents and 4 students on it? Do those people have jobs? No. So that's a combination. If I pick 3 parents and 2 students, I have to give them jobs in order for it to be different. You have to give them jobs. Because those 3 parents I pick, is their job any different? No, you're just going to pick parents from parents and students from students. That's it. So the key thing is if you're forming any type of committee or something, they have to have different things, different jobs, going to different places, different prizes. So let's look at example 1. A student must sign 3 different books out of the library to read for her English class. She has always returned her books on time, so she's allowed to take all 3 at once. How many different ways can this be? Does the order in which she picks these books matter? She's taking all 3 and she's going home. No. So is it a permutation or a combination?
Combination.
Combination. And so I'm going to go 3 books, C, 3 books, which is 1 way. That makes sense. She walks up to the library. She says, hello, Miss Librarian. Can I please take out these 3 books? The librarian says, you're in good standing. She goes, beep, beep, beep. She hands her the books back and she walks out. 1 way. That's it. She walks up, gives her the books, she walks out. Correct? B. Another student must sign out 3 different books, must sign 3 different books out of the library, just like A, to read for her English class. She is in bad standing with the library, can only take 1 book out at once. So she take out 1 book, she has to read it, she has to return it. They have to say, okay, you returned it, and then she can take out another one, return it, take out another one. Yeah?
Is writing 3C3, is that enough to show your work?
Yes. So, does the order in which she picks the book matter this time? Yeah, she takes 1 out. She has to return it. Now she gets to, that was 3 options, correct? She returns that one, now she has 2 options of books. She returns that one, and now she gets to read whatever one she didn't pick up. So this is a permutation. And if it's a permutation, I can use blanks if I want to. I can say this is the first book she's taking out, the second book she's taking out, the third. So she would have 3 options for the first book takeout. And then she would have read one. She's not going to read that one over again. So then she would have 2, and then she would have 1. This is also the same as 3P3, which is 6. Try example 2. They're just going on a trip. So they're going on a trip or they're not, right? So that would be 10C3. No special if they go or they don't go. Or if they're picked or they're not picked. 3 students from a class of 10. The first goes to Germany, second to Toronto, and the third Walmart and Okotoks. Special as Walmart and Okotoks is. The order does matter, so it'd be 10P3.